Assalamualaikum and hello to everyone. So in this video, I will be sharing with all of you on how to fill in the cooling load estimation table based on what we have learned so far, which is the space characteristic and also the solar heat gain. Okay, so we will use this question as an example on how to fill in the table. So we have here, okay, a space which is used to general office. Okay, we will use the space for general office. So there will be an estimated of 50 staff. Okay, and the this room condition. Okay, so the room condition is 75 degree Fahrenheit, 55% relative humidity, and also 72 grains per pound specific humidity. So the question asks us to estimate the peak cooling load requirement based on the following construction details as in the table here for the month of May 2020, okay, 2020. So here we have the space characteristic of the office. Okay, so we have the room size, we have the wall building material. Okay, so you can see it's 4.5-inch brick wall, cement plaster on both sides. On the east side of the building, we have glass, okay, as you can see in the floor plan also provided in the question. We have 4 units of window, and each of the window is 6.5 feet times 5 feet. Okay, the type is a single regular plate, quarter inch, okay, the thickness. There are no shades. No shades here refers to that there are no trees or no high-rise buildings blocking the window, okay. But inside of the window, on the inside, there is a internal medium color blind, okay. And then on the west, there's also 4 windows. Okay, the size of the window is given. The type of window is the type of glass is given. Also, there are no shades, there are no trees, there are no buildings blocking the window. But inside of, on the inside of the window, there is internal dark color blind. Okay. On the south glass, okay, we have see here we also have 4 windows. Okay, the size of the window, the type of the glass, no shades also blocking the glass, and also inside of the on the inside there is a medium color blind. In terms of door, okay, there are glass doors. Okay, there are 2 units on each of the north and south wall. So on the north side we have 2 doors made of glass. On the south side also we have 2 doors made out of glass. Okay, so the size of the dimension of the doors, 5 feet wide, 7 feet high. Okay, on the roof, okay, so this is a single story, okay, single story office building. So the roof is congregated asbestos with suspended ceiling board. Okay, so the lighting used for this office is 4 watts per square feet fluorescent type. Okay, so this is the floor plan. On the floor plan there is the dimension and also the location of the doors and windows. Okay, but first, before filling in the cooling load estimation table, we have to calculate the area, okay, with respect to the side, north, east, south, west, also the roof or ceiling, and also the floor, the area. Okay, so for the north, okay, we have the north side, the length is 65 feet, and from the table we know that the ceiling height is 10 feet. Okay, so for overall it's 65 times with 10. Okay, so we can get 650. Okay, for windows there are no windows, so we just can leave a blank or dash. For doors there are 2 doors. Okay, and then the size of the door is 5 feet wide times with 7 feet high. Okay, so we can get 70 feet square. Okay, so when we want to calculate the wall only, we just subtract the overall, okay, with the door. Okay, so we can get here 580 feet square. Okay, so we do this for the east, south, and west. Okay, so for the east also overall is 650. There are 4 windows. Okay, each window is 6.5 feet wide and 5 feet high. So this one we can get 130. Okay, and then there are no doors, so we can leave it blank or dash. So the wall only will be 650 minus 130, so we can get 520. Okay, so for the south, okay, overall is also 650. Okay, so based on the dimension, so on the south we have 4 windows also. Each window is 6.5 meters, 6.5 feet wide and also 5 feet high. So we can get also 130. There are 2 doors. Okay, so 2 doors. Each door is 5 feet wide and 7 feet high. So we can get 70 here. And to calculate, so we just minus 650 minus 130 minus 70. So we can get 450. For the west, okay, overall is 650 also. There are 4 glasses. Okay, each glass is 6.5. Okay, times 5 equals to 130. There are no doors, so this one we can get 520. Okay, so next is the ceiling or roof, but this one is a 1-story building, so there's only roof, there's no ceiling. So roof is the area of the roof will cover the entire floor. So the entire floor 65 feet times 65 feet, so we can get 4,225. So the floor area is also the same, 65 times 65. Okay, so 4,225. Okay, so we have to calculate the area first based on the sides and also roof or ceiling and also the floor. Next, we can fill in the cooling load estimation table. So for space used for, we know from the question it is a general office. So we can fill in the name general office here. And then for office, in terms of equipment operation, so for office, we can either choose 12 or 24, but logically, for office hours, it's mostly 12 hours per day. Okay. So for the size, the dimension of the room, 65 feet times width, 65 feet. Okay, so we can get the area here, 4,225. And we must multiply it with the height. Okay, the height of the room is 10 feet to get the volume. Okay, so volume here is 42,250. Okay, next is to fill in the psychometric analysis. So this one is based on the design condition, okay, which we can get from table 2. Okay, table 2. Okay, so here we have, sorry, not table 2, but page 2. Okay, so we have the design condition here. So for outside, we will take for outside here, we will read for the day values. Okay, so 92 for dry bulb, 80 for wet bulb, and 60 for relative humidity. Okay, for room, okay, it's also given in the question. So 75 dry bulb, wet bulb is 64, and also percentage humidity is 55%. Okay, so we fill in these values into our cooling load estimation table. Okay, so 92, okay, 80, 60, and for grams per pound, the outside air inside the video and the notes, okay, we have the value 136. So dew point, we can just put a dash, okay, because it's not required. For room, we know it's 75, 64, 55, and for room in the question has already given 72. So this one dash, and then we calculate the difference. Okay, so 92 minus 75, we can get 17. Okay, this one we get 16. Here is 5, and here is 64. Okay, so if possible, you highlight the values. Okay, so on the next, on the right, ventilation. So number of people from the question, 50 people. Okay, 50 staffs. And then times with the value for CFM per person. This one we have to look at table 11. Okay, table 11. Alright. Table 11 here. Okay, so under the application, we choose the exact or nearest. Okay, exact or nearest application. Okay, so we have here office, and also we have here general office. So if we have the exact one, it's will be easier. But if we don't have, we have to make assessment. Okay, choose the nearest application. Okay, the nearest most logical application. Okay, make a small assessment regarding our space. So once we have our application, we will look under the CFM per person. We will read for the recommended value. Okay, so for general office, recommended value is 15. Okay, so we will use the value for 15 here. Okay, and we can calculate the value. 50 times 15 is 750. For square feet, we write the area of the floor. Okay, 4,225 times width. The CFM per square feet, this one is in table 1. Okay, so we open table 1 here. Okay, table 1. Again, we look at the application. Okay, and we choose the exact or nearest application. So for office, general office, we know that the most logical, the nearest application will be inside a office building. Okay, so office building. Okay, so once we have selected the application, we will go to the fresh air column. Okay, we will go to the fresh air column. Alright, and we will read the average value. So the average value here is 0.25. Okay, so you read the average value. So inside you will fill in 0.25 and we will calculate. This one we will get 1556.3. We can leave it at 1 decimal point. Okay, for air change, this one we have to read the question again. Okay, so if the question does not give the value for air change, we will put it as 1. Okay, as per in the notes and also in the video. So here they don't give the air change, so we can put it as 1. Okay, so air change is 1 per hour. For volume over 60, we have the volume 42,250. We divide it by 60 first. So when we divide it by 60, we will get 704.2. Okay, so 1 times 704.2, we can get 704.2. So we have 3 CFMs here, so we highlight the highest value for CFM. Okay, because why? Because when we design for the maximum condition. Okay, so the maximum value for CFM will be used later. Okay, we will use the value later in our calculation. Okay, now we go into the solar heat gain. Okay, so solar heat gain is the heat gain from exposure to the sun, direct exposure. Okay, so we have wall. Okay, this one actually don't have. Alright, later I'll explain to you why. Alright, so we have wall and we have glass. So for wall, okay, the one which side will get direct exposure from the sun when the sun rises in the east and sets in the west. Okay, so we know when the sun rises, it rises in the east, and when it sets in the west. So in the wall side here, we only feel for the east and also the west. Okay, we don't have to fill in for the north and south. North and south we will fill in later in the transmission heat gain. This one we will fill in for the direct exposure from the sun. Okay, so east and west. Okay, so for area east, we can get from the table just now. So 520. Okay, we solve it one by one. Okay, so for east 520. For CLTD, we will open table 7. Okay, so table 7 here. So table 7. Okay, we look for east exposure. And then we look at our wall material. So our wall material in the question has given us that the wall material is cement plaster, 4.5 inch brick wall with cement plaster on both sides. So the weight is 60 pounds per feet square. Okay, so here we have 60 and we will read for the value of east, so 16. Okay, so inside the table we will use the value for 16. And then for table 9, U here there is the transfer coefficient, heat transfer coefficient. So we will look at table 9. Okay, so now our wall, our east is on the external side. Okay, So for external wall, 4.5 inch brick wall, cement plaster on both sides. The value for U is 0.48. Okay, so we can use the value here 0.48, and we can calculate the total. So we can get the answer is 3993.6. Okay, so we do that for the west side. Okay, so the west side, the area is 520 also. Okay, for CLTD, we open back table 7. Okay, we open back table 7, same. We look for the west. Under the same column, brick wall, we take the value 30. Okay, so fill in the value 30. And also the same, table 9, U, external wall. So the value will be the same, 0.48. So here we can get the answer 7,488. Now, just now I deleted the wall because why? Now I'll tell you why. Because our building is single story. So if there is a roof, we have to fill it here. Roof. Single story building. Okay. So description, we can just put a dash. The area of the roof we have calculated just now, 4,225. So 4,225. Okay, for CLTD, we don't look at table 7. We have to look at the material. Okay. Now for our roof, our material is congregated asbestos with suspended ceiling board. So if our roof material is not concrete, for CLTD, we will use the delta T for dry bulb 17. Okay, if our roof is not concrete. Okay, if our roof is concrete, we will use table 8. Okay, all of these are in the notes and also in the video lesson. Okay, so since our roof is congregated asbestos with suspended ceiling board, we will use the delta T for dry bulb 17 degrees Fahrenheit. Okay, for U, we will open table 9. Okay, so for roof, okay, we look for congregated asbestos with suspended ceiling board, and we read for the value of U, 0.28. Okay, so 0.28 here. And then we can calculate the total, so 20,111. Okay, so that is for wall and also roof. Now for glass, okay, for glass, we have to fill in every side that has glass. Okay, every side that has glass. Okay, so on the north we have door, and the door is also made of glass. On the east we have windows. Windows are made of glass. On the south we have doors and also windows, which are both made of glass. And also on the west we have windows, which are also made of glass. So all of this has to be filled. Because why? Because all of the sides has glass. Okay, so on the north, our doors are glass, so the area is 70. Okay, table 4, for the solar heat gain factor, SHGF. So we open table 4 here. Now the question asks us to calculate for the month of May. Okay, May 2020. So we look for the month first, and then we look at the exposure north side, and we read the value 48. Okay, so here we pull in 48. Now next times with table 5. Table 5 is the cooling load factor. Okay, so cooling load factor, we look for the exposure again, so north. Okay, so we have the exposure north here. Now we have 3 options here, 150 and over, 130. From the notes and the video lesson, I have already mentioned that we are going to use the value for 100. Okay, because why? Because our brick wall is 60 pounds per feet square. Okay, so we choose the nearest and also highest. Okay, we cannot choose 30 because it will not be enough. So we choose the number which is higher than 60. Okay, so 100. And then we will look at the operation hour. Okay, so we have just now said that the operation hour is 12 hours. So we will look at the 12-hour operation, and now we look at the shade. Okay, of the shade. So for the north hand side just now, okay, there are no shade. Okay, in the question, okay, they don't write for the north side. Okay, so we can assume that it is bare glass. Okay, means no shade. Okay, no shade. So for north, okay, no shade, the value is 0.95. Okay, so we will fill in here 0.95. Okay, next is the table 6. Table 6 is this shading coefficient. Okay, so our material of glass is regular plate. Okay, and since there is no shade, so the value is 0.94. Okay, so 0.94 here. Okay, so we can calculate the total, which is 3005. Okay, on the east, okay, back to the table, we see that they has windows, so 130. Okay, back again, table 4. This time for the east, so table 4 here, for May, east is 152. Okay, so 152 will fit in here. And then table 5 again, for east 100. For east, now there is internal shade. Okay, so from the question just now, east has internal medium color blind. Okay, so internal color blind means internal shade. So for east internal shade, so the value is 0.19. Okay, so here is 0.19. And then we refer to table 6. Okay, so inside blind, okay, medium color. Okay, medium color, so the value is 0.65. Okay, so 0.65 here. So the total is 2440.4. Okay, for the south, okay, for the south we have windows made of glass, we have doors made of glass, so we have to add them up. So 130 plus 70, we get 200. Okay, from table 4 again, we look at table 4, this time for south. So south is 14. Okay, so we fill in 14 here. For table 5, the cooling load factor for south. Okay, for south here, we have internal shade. Okay, from the question, from the south, we have internal medium color shade or internal medium color blind. Okay, so internal color blind, so here is 0.51. Okay, 0.51. So we fill in here 0.51. And then we look at table 6. Okay, same type of glass, regular plate, quarter inch, medium color blind, 0.65. Okay, 0.65. Alright, so this is 0.65. Okay, so we can get the answer here. Okay, so 200 times with 14 times with 0.51 times with 0.65. Okay, let me check again. For the south, 0.65. Okay, so here we can get the answer 928.2. Okay, so for the west we have glass, okay, windows 130. Okay, times with the solar heat gain factor, table 4 here, sorry. So on the west, okay, 100. Okay, internal shade. Okay, on the west there is a internal shade but dark color. Okay, so dark color. So internal shade here is 0.72. Okay, 0.72. So here just now is sorry, we have to look at table 4 first. Okay, table 4 is 152 also. Okay, so 152 here times with the cooling load factor. Just now we have read 0.72. Okay, 0.72. Okay, and then for the shading coefficient, regular plate, dark color is 0.74. Okay, 0.74. Okay, so we can calculate the answer here, the total. Okay, 10,528.1. Okay, so once we have all the values here, we can add them up. Okay, we can add them up. Make sure you add them up properly. Okay, don't miscalculate the total for solar heat gain. Because why? Because it will give effect to the calculation later. Okay, 10,000. Sorry, this is 5 to 8. Okay, so we will get 48,000 if I'm not mistaken, 489.8. So this is the value for solar heat gain. We can also highlight the answer. Okay, please try to calculate again. Okay, maybe there are mistakes, so you can ask me later. Okay, so thank you. Okay, we will continue with the remaining parts in the other when we have covered the topic. Okay, transmission heat gain, internal heat gain, and also the final calculation. Okay, so thank you.